Academy. We are still dealing with naming organic compounds. I just wish I can have all the time to explain all these things because we have numerous organic compounds. But let's take these three examples, then we go further to other things remaining in organic chemistry. We are still naming organic chemistry, organic compound. Just remember all the rules we have obeyed till now. I always ask students, in case you are finding this thing difficult to name it like this, but for me, I don't have issues with this. But in case you are finding it difficult to name it like this, expand it. What do I mean by expanding it? Look at this CH3 here. CH3. This is H, this is H, this is H. This is for this one. Now for this one, CH2. Look at the two H here. For this one now, CH, and it has a functional group here, OH. For this one now, CH, and this in bracket implies a branch, CH3, and now CH3. Or you can still expand this one, put this one H here, put this one H here, and you put this one H. Let's expand this one if you wish. So if expanding it will make it easier for you to name, no problem. So if we should consider all the rules we have streamlined in our channel and in our Facebook page, you will believe me that this compound belongs to alkanol because of the presence of OH. OH is the functional group. Functional group is that radical or group of atoms that takes you to a group of organic compound. It directs you to the family of that organic compound. So anywhere you see OH, it will tell you that it belongs to alkanol. Remember, I told you in the previous videos, there are some cases where OH will function as a mere branch and may not function as it may not act as a functional group. But here, it is acting as a functional group. And I think I have cited one example where OH is not acting as a functional group, but as a mere substituent group. So from here now, you start considering the number, the side you will start numbering to give you the lowest number. If we start here, 1, 2, 3, carbon number 3 carries the OH. If we start here, 1, 2, 3, the same carbon number 3 carries the OH. But I would prefer to start from here. I prefer to start from here so that this substituent group, remember, after numbering your carbon chain, anyone that does not fall in that thread is considered as a branch. So my numbering will start here 1, 2, 3, 4, and what? 5. Don't forget, I am considering the side that will give me the lowest number to the functional group, which is that OH you are seeing there, hydroxyl group or hydroxyl group. So after numbering it now, you know your root hydrocarbon has 5 carbon atoms. And the prefix for 5 carbon atoms is simply pent. Don't forget, I gave you all the prefixes. Don't forget. Now, the name of this one is very simple now, as we have numbered it accurately. So, you start from the substance group 2-methyl, pentan 3 or I always write 2 names in case it is this kind of thing comes out in the OBJ, you know what to do. It can also be written like this 2-methyl 3-pentanol. Both of them is 100% correct. Remember, Y2 here, carbon number 2 carries a methyl group. CH3 is a methyl group. Carbon number 3 carries the functional group, which is the OH. That is why it is pentan 3-ol or 3-pentanol. Don't forget. That is the name for this first one. Look at it once again as we are going over to the second example. Going over to the second example, if you watch this one belongs to a group we call alkane. How do I know that it belongs to alkane? That is why you need to know the functional groups. It is because of the presence of a double bond. Double bond is telling us that any compound that has double bond, it belongs to this family of organic compound called alkene. Now we can as well expand it or just name it. This is a CH2. This one you are seeing there. This is the double bond there. This is that carbon. This is this one now, CH2 with a chlorine group there. This one is CH3. So I have expanded it and we need to start numbering. Remember, we will start here. 1, 2, 3. Why do I prefer to start here? Because it gives me the lowest number to the functional group. If I should start it is 1, 2, 3. The same root carbon of 3, but I'm considering the side that will give me the closest number to the functional group. Don't forget, it is very, very important. That was why I decided to start from here, so that carbon number 1 will be the one carrying the functional group. Okay, the name is now looking at us now. What is now the name? 3-chloro, 3-chloro, 2-methyl, prop-2-ene. Let me write it again. 3-chloro, 2-methyl, 2-propene. Why is it like that? After numbering our carbon chain, we see that carbon number 1 carries the functional group. Carbon number 2 carries the methyl group. CH3 is here. Carry CH3 here. I can still number it from here so I can see it clearly. What are we numbering? We are numbering carbon atom and not other substituent group. So carbon number 1 carries this. Carbon number 2 has a methyl group. Carbon number 3 has a chloro group. That is why I will start from the chloro, because we have two substituent groups. We have this one and we have this one. And this one is a methyl. This one is a chloro. I know why I'm writing this thing. Rule of alphabet will have to play a role here. C and the N. Which one comes first in the alphabet? I believe the answer is what? C. That is why I first of all number C. First of all, name chlorine before naming methyl. So the name of this compound is 3-methyl. Sorry, 3-chloro, 2-methyl, 2-propene, or prop-2-ene, as the case may be. Example number 3. Just keep looking at it once again. Example number 3. The functional group present in this place is CO. And the CO is the functional group of what? Alkanol or ketone. That was why I first of all thought about the functional groups we have in organic chemistry, so that anyone you see, you will not find it very, very difficult to comprehend. So it is alkanone or ketone, that is the functional group present in this compound. I can name this thing comfortably, but you can still expand it if need be. If you watch this thing very well, if you start here to number 1, 2, 3, 4, 5, and 6. Our root hydrocarbon is 6 carbon atoms, which is Hes. And don't forget that carbon number 5 has a substituent group, which is a chloro group. And the almighty carbon number 3 is the one that has our functional group, the ketone functional group. So the name of this thing is simply 5-chloro, 5-chloro, 3-hexanone, 3-hexanone, or 5-chloro, hexan, 3-ol. Anyone you prefer, both of them is 100% what? Correct. Don't forget, I started here to number Because if I should have started here, it could have been 1, 2, 3, 4. It would have been carbon number 4 that has our functional group. But if you start from here, it's carbon number 3. 3 and 4, I guess 3 is the closest number than 4. So watch that thing very well and let's go over to the second one we have. Happy watching.